All right, everyone, I'm going to go ahead and get started. Thank you for coming to my session today. My name is Kisa Brostrom. I am the VP of Data at boodleAI, and I'm here to really just talk to you about how to get the most out of your data. I've spent a long time building different infrastructures at different companies. And oftentimes I use this phrase, help me help you. A data team has to be supported in order to really support the company. And so hence the title, help me help you, supporting your data. So a little bit more about me. Like I said, I am currently the VP of Data at boodleAI. I actually have a bachelor's in mechanical engineering, so not a traditional data scientist. I graduated from Washington State University with no computer programming knowledge, no advanced analytics knowledge. I had a single intro to statistics course underneath my belt, which is to this day the only course for my undergraduate education I've ever used. But what studying engineering really did for me was it taught me how to dissect a problem and make sure that my solution integrated with the whole of the component. And so what I mean, and that has served me really well. And that's really what the foundation of this talk is how to make sure the solutions you are getting from your data team integrate with your company as a whole. I don't think anybody would argue that data in today's world is a very useful tool. It's oftentimes said, he who controls the data controls the world. I would argue that even though that is slightly true, it's more he who can use the data controls the world. And throughout my career, as I've worked for different companies and consulted with different companies, what I've often found is that a data team will kind of spring up out of this, like, oh, I have this data question, I should have a data team. And they become this data professionals are not cheap, this very expensive components. And if they're not properly supported, basically the things that you can have a great model, but if you don't have any way to use it well, your data teams become this very kind of expensive paperweight. And it creates a lot of an antagonistic relationship between them and the rest of the world. It can become kind of this ubiquitous black hole. And so I'm here to help you try to avoid that. So right after I graduated, I was hired by Rolls-Royce. Fun fact, Rolls-Royce is actually not the car company. They haven't made the cars since like 1996. BMW makes the cars. So no, I did not work on the cars. I did not get a company car, which is oftentimes everything I'm asked whenever I tell anybody I worked at Rolls-Royce. So I worked at Rolls-Royce, and I was hired on as a performance and reliability engineer. And it turned out it was a data scientist, data engineer supporting the performance and reliability engineering team. So I trial by fire, I learned Python and SQL and R and Scala and Django and Flask and Ruby, HTML, JavaScript, advanced statistics, machine learning, all at that. I got a real full stack experience from database development all the way through front end web application development. And that has served me very well. After I decided I loved data, so after there I went and over to a media agency called Canela Media. There I was the senior data scientist. I was the very first data science hire on a brand new data team, and I was hired to build out their data team, their data infrastructure, and their data portfolio. Became the head of analytics there, and then moved over to another startup company where, once again, I was one of the first data hires, and I was there to build out their data team, their data infrastructure, and their data product portfolio. Unfortunately, due to COVID, they ended up releasing their entire data team there, which was actually okay. It was good timing for me. I ended up I was 2 days before my due date with my third daughter. So I ended up taking off my maternity leave. And then when I came back into the career world, I was hired on at boodleAI as the VP of data. Boodle is a VC-backed people analytics focused SaaS platform where we're helping people really utilize their first-party data by giving them an easy-to-use platform and also integrating it with third-party data. And again, I was hired there to help build out a data team, their data science capabilities and data infrastructure. So there's a theme here is I have spent most of my career helping make sure that these data teams are built out, supported, and used to the best of their abilities. So oftentimes what I find when I either consult or I work with or I work at a company and I come in is most companies focus on one or two aspects of the data project, but fail to support the entire life cycle or fail to really even consider the entire life cycle. The life cycle of a software engineer of like a software project is very well understood. The life cycle, the sales cycle of a company is very well understood typically. Data science typically is not thought of in this project life cycle. It's thought of, oh, you're just gonna go analyze this and then come back. But that's not the case at all. There's a lot of infrastructure and support that goes into making a really solid maximum benefit from a data project. And when you fail, again, when you fail to consider that entire life cycle, you're not setting your people up for success. You're not setting your company up for success because you can't get the maximum benefit out of it. Again, you can build the greatest, you can have the best data, you can build the best model, but if you don't have a way to implement it, if you don't have a way to monitor it, if you don't have a way to teach people how to use it correctly, then ultimately it's just a really expensive science project. So one thing that I am by no means the expert. There are 1,000 different ways people will present this. But what I am really good at is making the complicated simple. And so this is my very simple representation breakdown of what the very complicated data project lifecycle is. Yeah, so the first step is obviously data collection. You have to collect all of your data. You have to make sure that you're tracking what you need to track, that you have access to the data that you're going to need. There's actually a step before this, that's requirements collection, but there's not really an infrastructure support to that component, so I've kind of skipped that. So I am making the assumption that you have good requirements here. So, but you collect the data, then you curate the data. This can be called data, and this could be called feature engineering, data mining, data cleaning. This could, I've heard the term used, massaging the data. This is really combining all of your data into one easy to use source for your analytics and data projects. Then you have your analysis and development area, that stage where people have to be able to scale up and scale down and iterate really fast. And they have to have a centralized location where they can exchange information with each other and really collaborate, or they can work with the software engineers. It has to be a really cohesive area, and you have to support that. Versioning is there as well. And then once you're done with that development, then of course you have the adoption, the implementation, the monitoring, this productionalization portion of it, where you actually have to go from having a great model to having people use your great model or analysis. And then one of the most forgotten parts of the life cycle, which I mean is truly, truly forgotten, is this impacted education. It is great if you can actually productionalize your product, but unless you can then go and become an advocate and say, hey, because of this analysis, because of this model, we have decreased churn by 30%, or we have increased ARR, the average ARR by, $100,000, that impact becomes very important for when you're advocating for additional resources, or you're advocating for just continuing on, having a continued need. Because again, data teams can become this black hole, this very expensive black hole where people aren't really sure what the value it is that they're getting out of. So you have to be able to speak to the value. Also, you have to educate people on how to use the products and the analyses correctly, because you can give them a lot of products, you can give them a lot of analyses, and they can go off and make wild assumptions based off of what you're saying. And so it is really up to you to make sure that they are using it appropriately and correctly. So awesome, I'm going to break down each one of these. Collecting the right data. The real important part here is collect the data you want in the future, not what you're going to use right now. It is very easy to focus on what is the data that I need for this specific project, but you really have to broaden your scope beyond that, beyond your analysis in this current projects. One, you need to make sure, we talked about impact a little bit. You need to make sure that you're collecting the data to measure impact. This needs to be decided at the very beginning so that you can make sure that you have those collection points. You need to think about what subsequent analyses can result from this project and what data you're going to need for those. A perfect example or a perfect scenario is the idea that a data project is not a destination. It is just like software engineering in the regards that once you create, you don't just create a software and then expect it to exist on its own and you maintain it and it's going to be great forever. You're constantly iterating on it. And the same thing happens with data projects. You do one data project and 7 new data projects spring from this. And so you really have to spend some time thinking about what subsequent analyses could result from this project and what data are you going to need, because it's much better the earlier you can find out what data you need and can get your team set upon collecting that data, the better, because there's nothing worse than you needing to do an analysis, you don't have the data, and then you realize you have to basically backtrack and try to rebuild this data that you could have started collecting 6 months ago. Do we have historical records of this data, or should we? Time series is often, historical state is often something that is completely overlooked, but a lot of times that is what is needed to measure things like impact, to look back. I once did a churn project, and we found out that churn was highly related to product usage and what type of features were enabled and product versioning. The problem with that is that churn is inherently a time series problem. So you're trying to figure out who's going to churn within the next 3 months. So this kind of this rolling window. Our product was not set up to track product usage or feature enablement historically. It only had current state. So we had to go through these like log folders and these log tables in order to try to rebuild the historic state of what was happening at that time when people were churning or not. That was really difficult. It would have been much easier had we just decided that we are eventually going to need historic state and then build it in and start collecting it from the very beginning. Honestly, my opinion is, even if you don't think you need historic state, you should figure out how you can support a historic state, because you most likely will need historic state at one point in time. And then where can you get that data? Data is available everywhere. I know you have data vendors, you have publicly available data, you have APIs, you have internal databases. There are 1,000 different ways that you can get data. And so you have to be able to support that. You have to have the infrastructure around to support that. So some considerations that you need to, you know, really think of is you need to have support for the different types of data sources. For things like web scrapers. Web scrapers are really simple to build, honestly. And nowadays, web scraping is very easy to build. So you just have to make sure you have the infrastructure to support that. Using APIs, calling them on a regular basis. Databases, this is whether or not it's your internal databases or a database from a vendor, making sure you have that support for that. You have to have you have to consider what your data model is going to be. I'm going to talk a little bit more on that in the next slide in data curation, because data model, a good data model will decrease your development time, like cut your development time in half. Because as we all know, data scientists spend about 80% of their time prepping their data before they actually get to the analysis or the model. You have to have support for your pipelines. You have to have a pipelining tool or a data engineer who can build a pipeline, or even a data scientist who can build a pipeline. Data scientists are more and more frequently becoming self-serve and self-sufficient. And so making sure that you have that, making sure that they have resources to build their own pipelines, if that's the way you go. And then of course, the personnel, you data engineers, data ops, product engineers. If like in my scenario, you need the product there to start tracking metrics from that specific feature or subproduct. Silo to warehouse. So this is the data curation stage. And data curation is really consolidating disparate data sources and establishing a source of truth. This is once you have all the data, you've collected all of it. Now let's put it all into one space. And when companies are first created, data is typically stored in silos. And it is not a simple project of just saying, let's throw all of our silos into one database. You have to one, figure out where all the data is stored. People will store data in databases, which is much easier to work with, but they'll also store them in things like Excel files, Google Sheets. Sometimes even they'll like copy and paste a table into a document, which is mind-numbing. And so you really have to, you know, they use all of these third-party products that have their own data storage, and you might be able to get them through APIs, but you have to know that. Perfect example is Salesforce. Salesforce oftentimes will have extensions attached to it that you can get to, but you have to use an API to get to it. So, so where's the data stored? What format is the data stored in? A lot of, you know, CSVs are great to work with, but you have a lot of times JSONs. Sometimes they're not even in a relational database, and they're in, sometimes you have relational databases, sometimes you have non-relational databases. You have columnar databases, you have Hadoop. You have to understand what the format is stored before you start kind of collecting them all. Time formats become really important in this too, especially if you're dealing with time series or historical data, which you should. This is the hardest one, probably the hardest question to answer is, what data model best supports the type of data analyses we will do now or in the future? A good data model, I can't say this enough, a good data model will cut down on the development time in half. And that's because a lot of times data analysts and data scientists will spend an inordinate amount of time just trying to get the data to where they need, in a format they need it in, and understand what data they should be trusting. And so a data model becomes very important. a good data warehouse has a data model that supports analyses. A database that supports product is very different than a database that supports analytics or data science. They're created in two separate ways. And I understand why product has to be created the way it does, but in equal consideration, when you ask an analytics team or a data science team to use a database or a data source that was designed for a very, very, very different purpose, you're not setting them up for success. So how to maintain an accurate sync and how often should that occur? This is very customizable, but it's something you have to think of, like how often does your data change in these different data sources? You know, if you're pulling an API full of census data, okay, well that changes, you know, that changes once every 10 years. So sync doesn't become so important. But if you're pulling from a subscription database where you get new users literally added every single day, every single hour, then it becomes really important to understand what your sync is, because sync can actually also cause issues with read and writes. So if you're trying to read and write while you are trying to sync at the same time, you can throw errors. And these are considerations that you have to take into account. There are thousands of tools that you can use to manage syncs. And then finally, the hierarchy of data sources. This is the source of truth. This is when you have two disparate data sources, two silos that basically conflict with each other. So one says this is a customer, one says this is not a customer. Or one says this person is 35 and the other one says this person is 72. Who do you believe? What do you believe? How? This is when you start gauging the truthiness of your data sources. And it becomes, you end up having to build very, very strategic logic in order to say, okay, use this one when this one is here. But if this isn't here, then, you know, then the next one in the line is this. These can be very simple as say, you know, this is 1, 2, 3, 4, go in that order. Or this can be very, very complex. And so you have to understand, you have to spend time really figuring out which one is the source of truth. So considerations, data sources, again, this is very similar to the one before this. You have to understand where your data is and how to get it to where you need it to be and what format it'll be in. Data model, we've talked about this extensively. If your data model doesn't support time series and historical state, you need to change it because you will, historical state and time series is so important. Pipelines, you have to understand the integrations with common tools. There are a lot of common tools that companies use. Salesforce, Shopify, Zora, Marketo. These are all things that have different ways that you interact with the data behind the scenes. Pendo is another one. Scheduling your syncs, like I said, there are thousands of different tools that can do this. You can build your own sync scheduler. You can use an out-of-the-box tool like Fivetran. There are lots of ways, but you do have to take into consideration how often do you need to sync? How is it going to be maintained? How are you going to flag errors? What's going to happen if during a sync it errors out and then you end up with corruption in both databases? How do you back up and restore those databases? These are things that you have to think about when you're going from silos to warehouses during the data curation. And then of course, source of truth we've talked about. Setting your team up for success. This is the development stage. Data teams need a platform for access and ownership. During the analysis and the development stage of models, oftentimes I have seen in companies where I will come in, they will ask me to do a specific project or analysis or model or whatever, and yet they don't actually give me access to the data. Or I don't have a centralized development area where I can access the data. So then I am going to this third-party tool where I am then pulling data. I'm transferring it from one virtual machine to another virtual machine. Heaven forbid if we have two different operating systems at that point in time. I'm downloading this data and then I'm uploading it into another thing. And then finally it's at a place where I can actually start interacting with it in a development space like Jupyter or SageMaker. I like SageMaker personally because there's a lot of good benefits to it. But so there's a lot of steps that data people have to go through just to get access to their data. And then beyond that, they don't really have ownership over the data. These are your data professionals that you've hired to be data domain experts. And a lot of times they are secondary partners to the first two steps, the data curation or the data collection of the life cycle. And so they don't really have ownership over the data. And so then again, it makes it very hard for them to say, hey, we need to change the way we're collecting data in order for me to successfully do my do these projects that you have me asking. So data development takes on many forms. It's very fast, it's very dynamic and very evolving. On the flip side, security is also important. A lot of times when I talk about this, people are like, well, but we have to maintain the security. There are lots of great security protocols and tools you can use that do not compromise security for performance. And so you have to have a balance between the two. You cannot ask your data teams to support the company efficiently and move quickly when you've tied both their arms and one of their legs behind their back. So in order to ensure the proper balance between the two, you really need to assign a central owner of all data within a company. And I know this is a controversial statement, and I know some people might disagree with it. But in my experience, every company I've worked for could have benefited from assigning one central person as the owner. Well, just like you have a product owner, you should have a data owner who sets up, who has control of that data within a company. This makes it much easier for when we need to start talking about data decisions. You need to create a secure development platform that scales. I remember I was once asked to create a neural network attribution model and I did not have access to a computer who actually could do neural networks, and I couldn't run. I couldn't scale it, and I was asked to do it over, you know, hundreds of gigabytes of data, and I had this puny little like 8 gigabyte RAM hard drive, and this was before we had gone onto the cloud because they didn't trust the cloud. And so I had no way of scaling. And so to train one model, it took like 23 hours to train. And it sounded like my computer was going to take off and become an airplane because the fan was running so hard and so loud. And so I understand there is security concerns, especially in light of a lot of the security breaches at all of these other companies. That being said, there has to be some dynamic between a secure platform and a platform that scales, and giving people access and giving the people who are doing the analyses and the models the ability to scale their platform without having to wait 3 weeks for a DevOps team to scale it for them. And so really you have to give them a secure development platform. Ensure easy access and integration of data from development platform. This is what I was talking about when oftentimes when I have to go through 7 steps to get data into the platform that I need in order to do my analysis and model. That's such an inefficient waste of time. It takes so much longer. A model that would take me 2 hours to build, test, and be comfortable with ends up taking me an entire day. That's a 4x time consideration when you're talking about just a basic, simple model. And So the more we can integrate data and give access in their development platform, the better. And then also just like security should never be compromised. Totally agree with that, but neither should accessibility. There are ways to balance the two considerations. So we talked about all of these considerations, the development platform, making sure it's scalable, accessible. Maybe, oh, one thing I didn't talk about was being able to share it between team members. That's that centralized component that I didn't touch on too much, but if anybody has ever tried to share Jupyter notebooks, like using GitHub or version it, I'm sure you've run into the situation where basically GitHub corrupts your Jupyter notebook by adding additional characters to the code behind it. And then you can't open it, and then you have to open it up and try to like manually adjust it. That it's just a nightmare. So making sure that you have a place that people can easily share development work between each other. And then also a continuation of that is making sure that you can transfer from development to production. We talked about ownership, we talked about security, and the personnel really needed for this step in the data life to support this data life cycle. This is a lot of data ops. This is whether you have a data ops team or you have just a DevOps team or a data engineer, machine learning engineer that can support it in this way. This is a real big stage where there has to be a lot of collaboration. Don't forget to AIM. So I created this acronym AIM. It stands for Adoption, Implementation, and Maintenance. So at the beginning of the project, this is very important, it needs to occur at the beginning of a project. You need to create an adoption plan, an implementation plan, and a maintenance plan. So these are probably some of the most forgotten aspects of data projects. A lot of times we focus solely on this development phase. How do we create this wonderful model or analysis? These are worthless unless people use it. You can build the most beautiful, sophisticated piece of data science out there, but it is worthless unless people will use it. So at the beginning of the project, I say that again, at the beginning of a project, ask, what is the final output of the project going to be? Is this a report? Is this a dashboard? Is this a model that people are going to want to use on some type of reoccurring basis? Is this a one-time model? Are you going to need to retrain it? Are you going to need to monitor it so that it can flag for when it does need to be retrained? Who is going to use it? How do I get it to them? What happens when it goes wrong? How do we know if it goes wrong? These are all things that you have to really take into account and have a plan. Adoption involves advocacy. Adoption is not whether or not you can actually implement it. It's whether or not people will actually use it. So this involves training. This involves integration into existing tools. The more you can integrate into the tools they're already using, the better. And this involves trust, advocacy, buy-in, which is something we talk about in the next step a little bit more. And then implementation. This is the productionalization part. This is whether or not it's using your BI tool and creating a dashboard, whether or not you're exporting a report, if you need to productionalize code and get it actually integrated into your product as a whole. Does this type of model need to happen on a schedule? Is it a recurring model? Is it an on-demand model? And then maintenance. This is how do you know your model is performing the way it is? What happens when it doesn't? You need to log, you need alerts, you need to have the ability to retrain and redeploy easily. And then you need duplicatable code. The fact of the matter is that a lot of the average lifespan of a data scientist at a company is 2 years. What happens when they leave? That code needs to be able to be picked up. Or what happens when they're busy with another project and something needs to happen? That code needs to be picked up and passed on and easily handed off. And finally, the so what stage. So the so what stage is this education and impact, which is, I mean, in the history of all life cycle projects, this is probably the least understood and the least prioritized. At the end of the day, a data team is an expensive resource. It just is. We're some of the most highly paid people within a company typically. ROI, education, and advocacy play a huge part in the ongoing health of your data team. So at the end of your project, make sure you have a plan to measure impact. It needs to be finite. It needs to be defined metrics that tie back to money. It all has to tie back to revenue, whether it's cost savings or you actually increase the revenue, something, efficiency savings or additional revenue savings. You need to publish and parade your results. It is not enough to be a silent winner. You need to let people know that you are winning. If your model is helping improve the efficiency of your marketing department by 50%, then that's something that it's great if you're helping them. I'm all about helping people do their jobs better and making it more efficient. But you need to publish and parade that results. You need to tell other people, yes, I have. You need to have a collection of, here are my past projects. Here's how much I've impacted the company. Publish and parade. Explain why people should care. Again, tie it back to the money and how it helps them. And then finally, explore the possible. Most non-technical people don't have a great idea of what they can do with data. They don't understand data. Even technical people, a lot of times, unless they're in the data, they don't understand what they can get out of the data. And this is really towards the data team specifically. It is your responsibility to help them cast that vision and explore that possible. So educate, you can do info sections, you can have a blog, you can have white papers, you can have case studies. I've done a data 101 at pretty much every company I've had. Advocate, get as high of a stakeholder as you can as possible, and then publish. A great way to publish is dashboards. And I see I'm running out of time. Last slide is a bonus slide. This is for the data analysts. If your company will not support you externally, you can always support yourself. I have been in every single situation. I have supported myself in every single possible area of here. So data collection, you can write your own API pulls and web scrapers. Data curation, you can host your data in a local SQL or even Google Data Studios sheets. Analysis, you can use SageMaker. Adoption and implementation and monitoring, you can build your own dashboards. You can schedule reoccurring jobs via SageMaker. And impact and education, you can schedule your own lunch and learn sessions. You can engage people early and often. There's always someone who is hungry to know more about data, and you just have to find them. And then tie it to the OKRs or your company goals, whatever system you use to track those. So that is the end of my presentation. I don't know if we have any questions, and that's totally okay if we don't. You're more than free to reach out to me if you want, but I thank you for being a part of the presentation today, and I hope you all have a great rest of the conference.
Thank you, Kisa. And it looks like we don't have any questions right now, but appreciate your time and hope everyone has a good rest of this year's DataCon. Thank you.